Hi guys, Assalamualaikum.
Waalaikumsalam.
How are you today?
Fine.
Have you seen the assignment that you set aside to us in Google Classroom?
No.
So basically, I have seen the assignment. So how about we choose our topic about ARM architecture, Non-Cortex, which is ARMv4 and ARMv5. So what do you know about that? Don't know?
I don't know it.
Okay, so let's watch this video.
Assalamualaikum and hi everyone. We are from group 6. We're going to present about ARM Non-Cortex, ARMv4 and ARMv5. Table of content in our slide. Non-Cortex ARMv4. It is being developed by ARM Holdings. The processor that I choose is ARM90920T. In architecture, with 32 bits RISC architecture, most instructions execute in a single clock cycle. It is also support 16-bit thumb instruction set. The purpose is designed for high performance with low power consumptions, used in mobile phones, gaming devices, and consumer electronics. In my right side, we can see the figure of ARM920T architecture. In this figure, we have instruction cache and data cache. Also, we have MMU, Memory Management Unit. So we go to the next slide. Is Non-Cortex ARMv5. It is also being developed by ARM Holdings. The common processor that I choose is ARM946ES. In architecture, it is also an enhanced version of ARMv4. It is also have DSP, stand for Digital Signal Processing Instructions for multimedia purpose. We have video. The new version of architecture has video, audio. The purpose is designed for more demanding embedded system. It is also provides higher performance while maintaining low power consumptions. The meaning is it is built for work quickly and efficiently, but use a little amount of electric energy. It is also suitable for multimedia devices, network equipments, or automotive system. In my right side, we can see the figure of ARM946ES architecture. In this figure, we have instruction memory and data memory. Also DSP, that stands for Digital Signal Processing. The difference between ARM version 5 and ARM version 4 is in version 5 we have instruction memory and data memory, but in ARM version 4 we have instruction cache and data cache.
For the computer architecture part, we will start with Non-Cortex ARMv4. ARMv4 architecture. For the CPU core, it uses a 32-bit RISC, which means the CPU will execute instructions and process data efficiently using simplified instruction set. The next one, for the registers, ARMv4 has 16 general purposes registers. First one is R13, which is equal to step pointer. It used for function calls and also local variables. Then the next one, R14, equals to link register. It stores the return address during a function call. And the last one is R15, a program counter. It contains the address of the next instruction to execute. So the next one, for the clock synchronizes processor operation and determines the execution speed. Then the last one for the system bus. It transfer data, instruction, and also control signals. The ARMv4 bus system consists of address bus, data bus, and also control bus. The next one is the instruction set. One of the key features of ARMv4 is their instruction set. It supports both ARM instructions and also thumb instruction. ARM instruction, which is 32 bits long, which is it can fast execute and also efficient processing. Then for the thumb instruction, it use 16-bit compressed instruction, which is it can make smaller program size and better memory utilization. Then the next one for the memory and cache. For the memory, ARMv4 uses a load and store architecture. This means data must be first loaded into registers before it can be processed. Then the next one for the cache system. Cache system so frequently use data as instruction, which is it will reducing access time and also improving overall processor performance. Then the last one, ARMv4. Application of ARMv4. ARMv4 was widely used in mobile phones, personal digital assistants, PDA, embedded system, consumer electronics, and last one, industrial control system. One of the most popular processors based on ARMv4 is ARM7 TDMI processor and also ARM9 TDMI processors.
My name is Muhammad Ahmad Zikri. So for my part is about ARM version 5, which is Non-Cortex ARM processor. Okay, so the first one, the register system use a 32-bit ARM register model with CPSR and SPSR register for processor status and system control. CPSR means current program status register and SPSR means save program status register. The second one, ARM version 5 use a change system to save store frequently used instruction and data. It has separate instruction and data change, and the operation are controlled through CP15. Okay, the third one is about the system bus. The system bus is divided into three parts, which is address bus, data bus, and control bus. This helps improve data transfer efficiently. And the last one is the advantage of ARM version 5 is low power consumption, small code size, and DSP support for multimedia application. Okay, so for this slide explains about ARM version 5 instruction and its application. So the first ARM version 5 use a load and store design where the data is moved between memory and register before processing. It also supports efficient pipeline execution, which improve performance. Another important feature is support for thumb instruction. For the thumb instruction, it uses a 16-bit instruction format, making programs smaller and reducing memory usage. They support basic arithmetic operation and useful for low-cost embedded device. And ARM version 5 was widely used in early smartphones, networking devices, consumer electronics, and industrial as well as automotive system. So I will pass to my next friend.
Hi, my name is Aliana. Today I was going to talk about the instruction cycle. First, what is the instruction cycle? The instruction cycle is the sequence that followed by the central processing unit to process instruction. It consists of three main stages: fetch, decode, and execute. First, the first stage begins the instruction cycle by retrieving the next instruction stored in memory. Second, decode. Decode is to determine the additional operations and operand required to execute and send their respective signal to the respective component in the CPU. Lastly, the execute. The execute is the actual operation specified to execute the instruction in the associate CPU functional unit. The results are stored in memory as required by this instruction. So, how data was processed in ARMv4? The instruction is fetches from memory using the program counter. The control unit decode the instruction identified as an arithmetic operation and prepare the operand. The arithmetic logic unit ALU perform the operation. So that's all for me. Let's pass to the next presenter.
Thank you, Alia. My name is Farah and I will explain the instruction cycle of ARMv5. ARMv5 executes instruction using 5-stage pipeline architecture. As shown in figure 1, the 5 stages are fetch, decode, execute, memory access, and write back. Each stage has a specific function that I will explain in the next slide. As you can see on this slide, table 1 shows the function of each stage in the ARMv5 instruction cycle. The fetch stage retrieves the instruction from memory. Next, during the decode stage, the control unit interprets the instruction and determines what operation needs to be performed. Then, in the execute stage, the arithmetic logic unit performs the required operation. If the instruction requires reading from or writing to memory, it proceeds to the memory access stage. Otherwise, this stage is skipped. Finally, in the write back stage, the result is stored in the destination register. To better understand the instruction cycle, let's look at this example on my right. The instruction is add R0, R1, R2. First, the processor fetches the instruction from memory. Next, during the decode stage, the control unit interprets the instruction and determines that the values in R1 and R2 need to be added. Then, the arithmetic logic unit performs the addition during the execute stage. Since the instruction does not require memory access, the memory access stage is skipped. Finally, the result is written back to R0 during the write back stage.
Conclusions. The ARM90T is a non-Cortex ARM processor designed for general embedded computing and operating systems, while the ARM946ES is an enhanced version for real-time and multimedia applications through additional DSP stands for digital signal processing instructions and improved processing capabilities. That's all from us. Thank you.
So, do you guys understand about ARM architecture?